Thanks for coming back, y'all. Today I want to teach you how to solve a system of equations by graphing. Broach did a little bit yesterday, and we're going to dig in deeper today. So you know the drill. Distractions off, brain on, write that title, and unpause when you're ready to go. So we learned yesterday that the solution to a system of equations, which is something like this, two equations used at the same time, is the ordered pair that's a solution to both equations. Somewhere there's an ordered pair that is a solution to this equation and to this equation both. Yesterday we made our two input-output tables, and it would just turn out that there was one that was on both. And that was the solution, we called it, to the system of equations. So how do you find it? That's where we are today. So there's actually three ways to find it. There's three strategies. The first is graphing. So if I want to find that ordered pair to these three equations, my first option to find it is graphing. So if you'll recall with me, when equations are in slope-intercept form, which these two are, we know two ways to make their graphs. One is to make an input-output table and then put the ordered pairs on the graph. The second way is to use the slope and the y-intercept. Say, okay, this one's going to start here, and it's going to change by that slope. You can do either one. For the sake of this one, I'll probably do one of each just to remind you how this works. So if I make the graph of both of these equations over here on this coordinate plane, I should be able to find the solution to the system pretty easily. So I'm going to do one of each. I'll make an input-output table for the top one. So x, y, I'm going to have to make it go down here. So I usually use, remember, I choose any x's I want. I usually choose these. And then I find out y. So I like to start with 0. So I put in 0 here. The opposite of 0 is 0, plus 4 is 4. The opposite of -1 is 1, plus 4 is 5. The opposite of -2 is 2, plus 4 is 6. The opposite of 1 is -1, plus 4 is 3. And the opposite of 2 is -2, plus 4 is 2. There's my ordered pairs. Now I'm just going to take those and I'm going to put them on the graph. -2, 6 is there. -1, 5, 0, 4, 1, 3. One of the reasons it's good to do several is they should line up, should be in a line. Mine are. I can't do this, but I always recommend to you, once you've got your ordered pairs down, use a straight edge so that your line's really straight. It is very important when you do this to be precise. If your line is not where it should be and is not straight, you may see the wrong solution and think you got it. So very, very important. I'm going to be extra careful here to really make this straight. You should use a straight edge because you can imagine if this line's in slightly the wrong place, you may not know the solution. I know where the solution should be, so I can be extra careful that it's there, but if you don't have a straight edge, it's really tough. So here's my first one. So one way to make a graph from an equation is to make the input-output table. If x equals this, then y equals this. The other way to do it, if they're in slope-intercept form, and these are, is I can use the slope and the y-intercept. So this one here has a y-intercept of 0. If you don't see a constant, that means the constant 0. You don't have to write it. You can write it. You can just jot it in. So the y-intercept is going to be here. And then it has a slope of 3 because it's in slope-intercept form. So what that means is each time x increases by 1, y increases by 3. X increases by 1, y increases by 3. I do that on my graph. X increases by 1, y increases by 3. Well, there's your solution right there. X increases by 1, y increases by 3. 1, 3. Again, now I've got enough points. You should use a straight edge. I know how to make the slope kind of work out for myself. But you'll even notice I'll be crooked. I'll get the points in the right place. At least the easy ones, but it'll be crooked. And so what we see here now, when we've got both equations on the graph, is there's a point there, an ordered pair, 1, 3, that's a solution to both equations. Let me prove it to you. The top one we already have, there it is. I already proved to you that if x equals 1, y equals 3. The opposite of 1 is negative 1, plus 4 is 3. What else I can prove to you is that 1, 3 is also a solution to this. If x equals 1, y equals 3 times 1 is 3. X equals 1, y equals 3. It's on both. That's the spot. And if you find it there, you've got your solution. And that's really all there is to it. Not too bad. Again, if I had made the XY table for the blue line, I would have found 1, 3 on it, and I would have known I had it. All right, let's do one together. First thing I want you to know today, there are 3 ways to find the solution to a system of equations. 3 ways. We're going to do the first one today, which is graphing. So here's your system of equations if you want to reinforce that vocabulary word. 2 equations, same time. And it's important to remember we've got 2 ways to create a graph from the equation. We can make an input-output table, or we can use the slope and the y-intercept. Again, I'll probably do one of each just to help you remember how those work. If you have a preferred method, you can always use the preferred method. So let's do that. Here we go. I think I'll make an XY table for this one. So I'm going to do that one first. So here's my normal inputs. If x equals 0, y equals 0 minus 1 is negative 1. If x equals 1, 1 minus 1 is 0. If x equals 2, 2 minus 1 is 1. X equals negative 1, negative 1 minus 1 is negative 2. X equals negative 2, negative 2 minus 1 is negative 3. I'm going to take that and I'm going to put that graph over here. So I need negative 2, negative 3 is right there. Negative 1, negative 2 is right there. 0, negative 1. 1, 0. 2, 1. And again, please, please, please use a straight edge to do this. I know where this is supposed to go, even past my dots, but if you don't have those, if you don't have a straight edge, it's really easy to make this end up in the wrong place and to think the solution's in a slightly different place than it is. So really, really important to use a straight edge. So there's the bottom one. The other way we can graph an equation, if it's in slope-intercept form, and it is to use the slope and the y-intercept. So this one has a y-intercept of 2, and then a slope of 2. So that means each time x increases by 1, y is going to increase by 2. X increases by 1, y increases by 2. So x increases by 1, y increases by 2. Increases by 1, y increases by 2. And again, need to use a straight edge because you can see the solution is going to be down here somewhere. And you've really got to make your line go in exactly the right place to make sure you find the solution. I know where it is. Over 1 down 2, over 1 down 2, over 1 down 2, over 1 down 2. And you can see that it's right there, but you can also imagine how if I drew my line slightly off, I might have thought it was here or here, and I could have missed it. So really important to use a straight edge. So there appears to be my solution. That is negative 3, negative 4. So let's go back and check. If I'm right, this ordered pair should be a solution to both equations. So if I'm right, y equals 2x plus 2. If x is negative 3, y should be negative 4. Is it? 2 times negative 3 is negative 6, plus 2, negative 4. Got it? What about the other one? If x is negative 3, y should equal negative 4. Does it? It does. Got it. This one wouldn't have been on my table, you'll notice. I didn't get to x equals -3. I would have had to go up another one here. So in this case, the graph helped me find it where I would not have found it on my xy table before. So there you go. That's what we're doing. We graph the two lines and we find the point where they intersect, and that ordered pair is the solution to both. In order to do that, you need to be confident using at least one method to make the graph, either the xy table or the slope and the y-intercept, or both. I did one of each just to help out, but either one is fine. Hope this made tons of sense, y'all. Give it another watch if not, and I will see you in class tomorrow.